Okay, today we're going to chapter 7, the last chapter. We're focusing on CLO4, where you need to know how to calculate the motion of rigid body using equation of impulse momentum methods. This one. Okay. Yeah. Okay, on my slide, you will see chapter 8, but actually it's your chapter 7 for this degree program. We'll look in momentum, linear and angular momentum, and then all the principal conservation, and we might skip eccentric impact if we don't have time, and this eccentric impact will be your reading material. Okay, so why do we need to learn this impulse and momentum chapter? It's because in our daily life, you have a tanker like this. Usually, you need to stop the engine before you arrive at a certain point to steer the big body on the ocean, right? So if you need to react before you see the port or before you see something, you need to avoid it. So you need to react before you hit the object, or you need to avoid that object. Okay, so that's why this chapter is important. We use impulse and momentum to analyze manner like this, and yeah. And here you are seeing a tugboat which is on the side of the big body. So the tugboat is another force vector that acting on the side of the boat that push the big tanker to one of the direction. Okay. So we start by introducing. Actually, you already learned this lah. So we just apply on the rigid body, right? So you already learned this in particles. You just apply in rigid body. So again, when you see a rigid body, we focus everything on the center of mass, which is the G. Yeah, everything on that center of mass. Okay, so just introduce again. What is linear momentum? Linear momentum is the product of mass and velocity. Yeah. L equal to m multiplied by the velocity at the center of mass. Okay. Now, center of mass can be two motion. It can be linear motion with its v velocity. If it have a rotation, then it become omega. Right. So here we are looking at linear. If you see linear, means you're looking at the straight line motion with its velocity and acceleration. But in this case, we only look at velocity. Yeah. So just recall linear momentum. We will use capital L. L equal to mass multiply velocity. The unit of linear momentum is kilogram meter per second. The unit for linear momentum is kilogram meter per second, and is a vector unit. It's a vector unit. So vector have magnitude and direction. Okay, so this one you've seen before. This diagram means on the body, and you have two interest points, which is P and I. So, and then there is a rotation on the body, omega. So to calculate the velocity of this VI is a summation of VP, this one, plus the VI stretch plea. So it means velocity relative to CP, right? So or you can write VI slash P equal to VI minus VP. And we know on the reference vector velocity, VI stroke P, you can convert into omega and R. V equal to omega and R. Yeah? So this is on the rigid body, linear impulse, linear momentum, where you can convert the vi/p or relative velocity to a certain point to become omega cross r. And the moment of particle of moment momentum, moment of something, moment means you take perpendicular distance multiplied by force or moment, right? So moment means there's a perpendicular distance multiplied by a perpendicular vector. So in this case, if it's moment of linear momentum, means you focus on linear momentum mv multiplied by the perpendicular distance. In this case, you take the r, the arm, the arm of the momentum, linear momentum, multiply or cross the mv. Yeah. So this is important because you will see this in your test too. This formula, HP equal to R cross mv. Okay, HP is a moment of linear momentum. Okay, the rest I will not go deep. Is a derivation of this formula. HP equal to R cross mv is a lengthy Cartesian vector analysis, so it is not our focus. If you go into engineering maths, then this is your what you will be tested, but dynamic, I won't test you this one, right? So this one will be your homework. Go and see the derivation, meaning the HP is a vector. Again, what is HP? HP is a moment of linear momentum. Linear momentum. What is HP is your MV. There's a direction. So MV, if you see K, K means go outside the screen. We're still using right hand rules. Okay. H equal to M MV multiplied by the R. Yeah. Let me see. Okay, so HP is this one, and then R is your MV. Your MV is you take VP plus omega cross R, put inside here, and then you put inside there, right? And then you do the crossing, you will get this one. But anyway, this is not the focus of this this part. But what is important is this one, this formula. Moment equal to R multiplied by the linear momentum. Okay. Now the rest is for your reading. For your reading, it's just a derivation. What I want to mention is HP. HP will arrive at 3 terms. HP will arrive at 3 terms. Let me see if I have that slides. At the end, okay, HP will be Y bar MV. So this one is still moment of linear momentum. MV is momentum y multiplied by the mass multiplied by the velocity in x direction is also moment of linear momentum. And this one is in x and then IP. But if your focus point, your O and a G is the same position, this one you cancel. Means your Y bar and X bar 0. Then your HG will equal this one 0, 0. HP will equal to IP omega. Okay. So what is important is that when you want to find the moment of linear momentum on the body, and the interest point is on the center of mass, you need to find I omega. So it's equal to I omega. I is I0 plus md squared. Okay. Or in other term, your Hg, linear of moment, linear of moment of linear momentum H equal to I omega. Okay. So these are the two equations. HV, the first one is R cross MV. R cross, this is a vector multiplication. This one equation. Or you can rewrite this equation into this equation. Okay. So IP and G, what is the difference? Means your G and P at the same location. It means that your focus point is the same point on the body. Yeah? Means your X bar and Y bar, you reduce until 0. G and P were at the same point. Means your focus point is at that point. Yeah? Then you have H equal to I omega. Yeah? So there are two formula. One is the cross products, and another one is direct use omega multiplied by the I. Okay, still the same, huh? How to find the I? I equal to Ig plus md square. Still the same, huh? I equal to Ig plus md square. This one you see X bar, Y bar is the D. It's a D, yeah? This one. Your focus point, the O and the G. This is your D. Huh? So if you have a case where you have a different point on the body, if you have different case, means your O and the G have a distance between the 2 points. What you need to do is memorize this formula. Or I will give you if I ask you this kind of question. So again, there is a typo error here. Y bar omega don't have the head. It's my typo error on the slides. And this one is X bar. Okay. So what is important is you know that there is a formula to calculate H, or moment of linear momentum. Okay. Okay. Just for info, in your test, you don't need this formula. For your test too, you don't need this formula. You only need this one 0, 0. You only need this one. Okay. Okay, the rest is your reading. It's a derivation of the products. Just for your reading. This one you go home and have a look. Right. This one also for your info. It's a loss of mathematics. I don't want to confuse you. Okay, so just recap. We have 3 motion in our rigid body: translation, rotation, and general plane. So if your object is having translation, okay, only translation, how do you find the H? Okay, now what is H? H is moment of linear momentum. Moment of linear momentum. So need to find what is the linear momentum. Linear momentum is mv. Mass multiply velocity. And then you need to find moment of linear momentum. So moment, the word moment means there is a perpendicular distance to that vector. So this is the vector. When you say moment, there's a perpendicular distance, you draw a line, and then there is a reference point to this line here. So in this case, it's D. If you take D perpendicular distance multiplied by the vector, you get moment. So this D perpendicular distance multiplied by this horizontal vector L, you get linear moment of linear momentum. It's a concept of moment. It's a concept of moment. So in this case, it's just a random in an arbitrary plane. We just put point A, and then there's a distance D multiplied by the L, you get linear moment of linear momentum. Yeah. So this one we already established. If you want to find the one formula you see here is the general formula for moment of linear momentum. If the point if the point of O and the center of mass is different, means your O and G is a different location, then you have these two locations, these two terms, Y bar and X bar there. So when a rigid body, they are rectilinear or curvilinear translation, because there is no rotation, your omega is 0. The third term there, IG omega, the omega is 0. And it only arrives at this formula. Okay, so linear momentum is mg, but and then your angular momentum is 0. Okay, so you know that you have two terms here. One is linear momentum, angular momentum. So if you only have translation, then angular component, there's no rotation. So angular component is 0. You only have linear momentum, which is L equal to mv. Then if the question asks you to find moment of linear momentum, what you need to do is take the L or mv multiplied by the perpendicular distance d. Yeah. Now, if you see the last question of your test 2, what you need to do is identify where is the center of mass, and then you predict what is the motion that you see, either to the left, right, does it rotate or not. If it's only translation, means it moves in a straight line, then you're having mv on that center of mass. Okay, then you draw a line, you'll be given a distance to that focus point or reference point. Then you take the d multiplied by the mv, you get h. Yeah. So just now is translation. What if the body rotate like this? You're rotating something. Okay. Now, application of this one will be, you will see in your test 2 question later. You are having a microsatellite that have 2 solar panels like this. So your question will ask you to find the linear momentum when it deployed like this. And then what is the difference if the 2 solar panel close the solar panel? What is the linear momentum? What is the angular velocity? Or will it affect or not? It will involve rotation about the fixed axis. So here, if a rigid body rotating at a fixed axis, you have 2 components. If the body rotates at the fixed point, you have linear momentum and also you have angular momentum. You have 2 components. So you need to find where is the center of mass. Center of mass always give you the tangential or tangent direction velocity. So you have L equal to mv. And because this one rotate, so rotate angular momentum we use h equal to I omega. Again, how to find I equal to Ig plus md square. The way here Ig means it just assume that the interest point O and the A or B or C is on the same spot. Then you are arrived at Ig. Yeah. So for the first 10 minutes or 15 minutes, we are repeating L equal to mv, H equal to I omega. We are repeating these two formula. Okay. So if the question asks you to find linear and angular momentum at the certain for the object at a certain point, for example, momentum at O on this object is a combination of two, which is I omega and R mv. Okay, you need to convert linear momentum into moment. This one no need already. Angular don't need already. Yeah, angular is here. You just transfer here to here, and then this one you need to multiply by the arm. You need to always convert the linear into something that rotate, or there's an arm in moment of momentum. Yeah. So if you have a rotation at a fixed point, you have two components you need to calculate. Especially when it asks you to find the h, angular momentum. So you have two. One because of the linear momentum, one because of the omega. Then we simplify. We simplify. If your V equal to R omega, you know that your V equal to R omega. You substitute inside and you factor them out. Do you see the I form? I equal to Ig plus md square. It still arrive at H equal to I omega. Yeah, we're still repeating the same formula. It depends on the scenario. So this is a general equation. You just need to remember if you need to find H equal to I omega and I equal to Ig plus md square. D is a distance between O and the interest point. Or in this case, O and the G will be your D square. Okay, so sometimes you see in a question, it will just mention use parallel axis theorem. Parallel axis theorem, it just means you are using H equal to I omega. Okay, it's still the same, but parallel axis theorem just asks you to use H equal to HO equal to IO omega, means you're referring to a pin or a fixed point. Okay. So again, this will you see you need to use this one in your test 2 last question. H equal to I omega. Okay. Now if you compare this equation and this equation, and you see this one, this one and this one, and you see this diagram, the last question of your test 2 will ask you, if everything the same, and now the mass is increasing, the object mass is increasing, what happened to your HO? Okay, H increase, what increase? IO increase, omega will increase or not? Why? You need to think. The question will ask you, if you increase mass, will it affect what will happen to the body? You need to explain. What will it happen to the motion of that object? You need to explain. I mean, how the object will behave. You think, You think. By referring to this formula and this formula. Because you're increasing your M, what will affect the formula? What parameter will change? Okay, IO will change. And then what it will affect? HO lah. What is HO? You need to, the question actually asks you what is H. Do you understand what is H? Okay, and what H will affect? It just affect the rotation of that object. Will it spin faster and faster or slower? You need to think. Or will it help the object to rotate faster? And so on. So you need to think. Okay, general plane is a combination between two. So this one, if it's combined two, then you're still seeing the same formula. It's just that if you combine two, we usually will use IC point, but it's still the same. You arrive at H equal to I omega. You still use I equal to IG plus MD square. But this one is more direct. You can just measure from one fixed point there. IC means the point do not move, like a pin. Okay, it's still the same concept. Still the same concept. And yeah, so if you compare side by side, H, if you want to find the moment at point A, is a combination of linear and angular, where you have I omega and MV multiplied by the perpendicular distance. It's still the same. It's still the same, like the rotation on a fixed point. It's the same. It's only when when the translation means moving in a straight line, then you don't have angular component. Okay, this one depend on your lab session. So if the equipment is not ready, then you will see in your lab 2 or lab 3. Okay, you will see this pendulum experiment. If no, then you will see your engineering lab or experiment 2 or 3. You'll see this one in your lab report. Yeah. So this experiment is a pendulum that you need to change the mass of this one, and then you count. How you rotate the arm at a certain degree, then you let go, and then you count how many swing that you can go until it stops. Okay. Okay. Then you add mass. Then you see how many swing it can make in a certain time and so on. Okay. So again, we're still repeating what is H. H equal to I omega. We're still repeating this one. I equal to H equal to I omega. So we have an example. There's an example. So if you have a rod like this, and you let go from the position, so the bar how will the bar behave? It will go down and rotate, right? So A will go down, point A will go down, B will go to the left, angle will become 30 to 0. And then the center of gravity might be shifting a bit when it was horizontal, might be, right? But it's still pointing down. Okay. So you're given a mass there. So determine angular momentum about this point. So you're calculating H equal to I omega, and your I equal to IG plus MD square. You're referring to the center of mass. So there's no D square there. Okay, you see, so about IC point, so it's easy. You draw the object, point A, point B. You put in central mass, put in W. Yeah. So you put in the velocity, because in rigid body last chapter, you are dealing with moment, a linear momentum. You're only interested in velocity. Yeah? So you put in velocity. There's no forces there in the last chapter. You only interest in velocity. I need to know where does the velocity go. Okay. So you put in this question, A will go down 2 meters per second. Although B also not given, but you only know the direction of VB. So you put in VB there on to the left, horizontal. Okay. And then you put in the distance between the 2 points. You can extract from the diagram. Okay. You go to the G, central mass, and you know that this one slanted, then the velocity will go this way. Right? So the VG will go down. And how to find IC is that you use your ruler. Remember, push your ruler, and the base of your ruler will align with the VG. And then the body, you draw a straight line. And then you join B, you draw up. A, you move to draw one line to the left. You will intersect one point. That point is called IC. Okay. And you know that it's 30 degrees. Yeah. Okay, so you can transfer the degree 30 in a zigzag form. You can transfer your 30 to here. And also this 30 degree here can transfer to there. Okay, how to find 30? Is it? Okay. So okay, you imagine your 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 bar lay horizontal, right? Then you raise it up. Your velocity will be, if you lay horizontal, will move to the left, right? So means the velocity, if you lay, it will go like this. But if you raise, it will slanted 30 degree here. Or you can see, because this one is 30 degree. If you are sitting on this point, you're sitting there. You actually, and this one fall down 30 degree. You are actually moving 30 degree towards the ground. You try to imagine you are sitting here, and then this rod fall down, free fall. Your body velocity will drop 30 degree to this direction. 30 degree, 30 degree. This one you go home and think a bit. Okay. So we transfer the length of BG 2 meter, G to A 2 meter. And I put in all the parameter. So this one, this line, because it's 90 degree. So this line is 4 cos 30. You're taking hypotenuse and the base. So it's a cos. So 4 cos 30 is this line. and the object is swinging clockwise, omega, at the IC point or intersection point or instantaneous center point. So you know that V equal to omega R. V equal to omega R, you rearrange V equal to omega R. Omega equal to V divided by R. This is the R. Okay, V equal to omega R is this V. The R is perpendicular. The relationship between your V and omega or an R. This is your V. This is your R. You know that V equal to omega R. This V and omega is perpendicular. I mean, these two vector is always perpendicular. So if V go down, your R will be this way, will be in perpendicular to your vector. It is this one. And the R is always referring, in this case, we use IC. So directly the R is A to IC. Okay, this one you can press calculator, omega 0.6 or 0.57 something. Unit is in radian, so you can substitute. Once you find omega, you can transfer the omega to all the point on the body, all the point on the object AV. Omega will be the same on all the point on the body. So you transfer V equal to omega R. So at the center of mass G there. So you know that here to here is 2 meters. So you know that linear moment of momentum or linear momentum, H equal to I omega G. So how to find IG? IG refer to the appendix. This is a bar. So if you look at the bar, appendix will be 1 over 12 mr square. So this one you read IXX IYY. Yeah, so your IG you read from the appendix. Omega you read from the previous answer. So your Hg will be 3.85 meter square, a kilogram meter square second. And is clockwise. You are at the center, so refer to IXS or IYY. Your length L over 2? Not the L, not the L over 2. No, the L over 2 in the appendix means at the center of that rock. Means that point is at the center of the rock. Then only you can use that formula. So this case is L over 2, L over 2 here. Then only you can use that formula inside the appendix. It's at the center, so it's have 2, 2. So it's L over 2 lah. So you can use IXX or IYY. If it's not center, then you cannot use that formula. Okay, so if it's not 2, 2, how do you do? You need to shift your interest point. Means you need to shift your point A or point B. You need to chop it off somewhere. But it's more complex. It won't happen in your dynamic. All right. Okay, so you already have the answer actually. This is another proving method that to prove that you're actually arriving at the same answer lah. So okay, so this is so there are two questions here. One is ask you on the center of mass, and then ask you one on the IC point here. H at G, there's one angular momentum about point G, which is this section on the left. And then another one, angular moment about IC point is here. That's why it still apply. H equal to I omega, but you need to calculate I equal to IG plus MD square. Then what is different is your D. Where is your D is here. IC to the G is 2 meter. When you substitute I equal to IG plus MD square, your D is 2 meter, then you get 15.4 kilogram. Kilogram meter square second. So I just put side by side to let you know what is the difference if the question asks you on the directly on the center of mass, and it asks you at a certain point away from the object. It's still using H equal to I omega. It's only the I value change. If it's on the spot of center of mass, then you use IG because your MD squared, the D is 0. If it's away from the center of mass and there's a reference point, you only need to find the distance between the O and the G. In this case, IC is O. O to G is 2 meters. So you substitute MD square here, the D is 2. Yeah. We're still using H equal to I omega. Okay, once we have the H, now we go into principle. Principle, you look at impulse and momentum. What is impulse? What is impulse? What is impulse? Impulse is what? Momentum, you know lah, mass multiply V. Just now you learn. What is impulse? What is impulse? It will related to what? Time. Force and time. So, okay, this is what you've seen previously, F equal to ma. And you know that A is a time differential of your velocity. dv dt equal to A. So you derive from here. You derive from here. F equal to ma. F equal to m bracket dv dt. And because this is rigid body, you always see there's a sub g there. You're referring to the velocity at the center of mass, or acceleration at the center of mass. So because the mass is constant, you can move the mass anywhere you want in the equation. So when you put inside m inside beside the v, you get what? Momentum. F equal to momentum time differential. Okay. Then impulse is what? Force multiply time. Force, when force multiply time, you get impulse. What is impulse? Integration of force multiply time means the F dt means you take the F equal to dt bracket mv, you integrate the first equation here. You on the left hand side, you'll get F d means you move the dt to the left. Yeah, F equal to dt mv, you move dt to the left and you start integrating. So F dt on the left hand side, when you integrate, you will get mv minus mv, mv2 minus mv1. Okay, left hand side is impulse. Then, because we don't like negative sign in our equation, we move mv1 to the left, then you get principle of impulse and momentum. Basically, it's from F equal to ma. Yeah, so this is called principle of impulse and momentum that you will see and you need it in your final exam. Okay, just remember principle of impulse. What is impulse? Force multiply time, or integrate time. Force integrate time. Momentum is mass multiply velocity. So what is happened before equal to what is after. Okay, so this is called principle of impulse and momentum. mv1 plus F integrate time equal to mv2. Okay. So just a reminder, every time general equation is important in your test or final exam, there are always marks for that general equation. So what does it mean if you draw diagram for this principle of impulse and momentum? mv1 is what happened to the center of mass and the velocity. So it means you only look at translation, not translation, because here you have I omega, there's a rotation, all right? So it have initial moment diagram, momentum diagram, something like this, plus the impulse diagram. Impulse means related to external force acting on the object. So this one, you see what is in the impulse, related to impulse. You have the weight, anything that have force, external force, and also the weight of the body. And also the moment on the body also can react, can be impulse. Then equal to the final momentum diagram. So they have 1, 2, and 3 diagram. Okay, so for principle of momentum, what you need to do in your diagram is you need to identify where is the velocity at the center of mass. Then you draw mv. And then does the object rotate or not? If rotate, then you need to put in omega 1 and plus the ig. Why ig? Because it's at the center of gravity. Constant center of mass, not gravity, center of mass. Okay, this one, impulse. Impulse related to all the force multiply time plus the moment. You take moment, multiply time, also impulse. So you need to identify all the force on the body, especially the W. W multiply time also give you impulse. External forces multiply time also impulse. Moment multiply time also impulse. Okay, so this one is impulse. And then the final one is, if the question asks you what happened at the end of the process, usually you only need to know the velocity, where the velocity go, and the rotation direction, omega. Okay, these two parameters, omega and V, you need to find. Okay, so there are many things. Most of the time, these all parameter here will be given. Here also will be given. You need to predict what is V and omega. Yeah, so this information will be given, this one and this one. You need to find what is omega and V. So how you find? Using this formula, principle of impulse and momentum. There will be something missing inside the formula there. Yeah. So if the body have general plane motion, then you need to use M equal to Ig alpha. M equal to Ig alpha. Just recall, this one you already learned in your particles chapter already. M equal to I alpha. And you can convert alpha equal omega t. So you can pull your dt out and you get I omega. You know it's I omega just now. H equal to I omega. This is angular moment. And you pull dt to the left, you do integration again. You pull dt to the left, you do integration. You arrive at this formula. M dt equal to I omega 2 minus I omega 1. This is moment of inertia. Moment of inertia. When you have general plane motion, then you need to establish this one. Okay, we arrange. So if it's rotate at a fixed point past O means you need to use I equal to Ig plus md square. This one, the I equal to okay. So it's the same, it's still the same. You just change your I into IO. Yeah, the difference between the top and bottom, this Ig is the O and the G is the same point. Yeah, then you can use Ig. If there's a distance, then you use IO equal to I plus md square. Okay, so this one, because you are having angular impulse here, this formula, or if you don't write the negative, you can move the negative to the left. You are arriving at one more principle. It's called principle of angular impulse and momentum. So you have two. One on the top is principle of impulse and momentum. This one. This one. MV and F, can say they are moved in a straight line. If the thing rotates, you switch from principle of impulse momentum to principle of angular impulse momentum, where you use this formula and not this formula. There are two principles depending on the case that you are having. Yeah. So you have three formula here. And you know that if you are moving in the linear form, you can break all the vector into two axes that you already familiar with it, x and y. You can break all the formula, all the vector that moving in the straight line, break into x and y direction. For example, velocity vector, you can break into vx, vy. Mass still the same. Same like the force. You add all the force and then you break into x and y, fx, fy. Time the same. And this one, Vg also same. You can break the final Vg and Vy. These two usually is missing. You need to solve this equation to get VGX. You need to solve this equation to get VGY. And then find resultant. How to find resultant? Square this one plus square this one square root. Then you can find the angle of final vector. Yes. Magnitude and angle. Because vector resultant, you have tangent theta, that one. Yeah? Yeah, just a side note. So let's say you have Vx and you find your Vy. Your resultant vector of velocity will be Vx plus Vy square root. How to find angle of resultant? This is your theta. Theta equal to inverse of your tangent y divided by x, or dy dx. Means the distance of a vector of y, this one and this one. In this case, you can take Vy divided by Vx. Yeah, so this is a trigonometry basic. Okay, then what about the rotation? Rotation, you only have one. Either clockwise or anti-clockwise. Whether rotate clockwise or anti-clockwise. By using your right-hand rules, still apply right-hand rules. So this one you have I omega plus mgt and I omega 2. So this set is fixed already. When the question asks you on principal angular impulse momentum or angular of linear impulse or momentum, sometimes we just take away the angular word. Principal impulse or momentum means two things. It means linear and angular. So it means there are two sets of equations. The yellow color is the linear impulse and momentum. The white color is angular impulse and momentum. Yeah, so this slide is important, or the most important slide in chapter 8. Yeah, so this will be the highlight. Okay, the rest is your reading. The rest is your reading. So that's why on the slide here, you see I omega m and I omega 2. The MV1 is linear. The rotate blue color arrow is the angular motion. Same with this one, the middle one, impulse diagram. All the force is the linear, W also linear, but you have M multiply T is the angular component. Same with this one, final momentum. Black arrow MV is a linear impulse and momentum. So this one is the omega square is the angular motion. Okay. So the rest you read. The rest you read. Yeah, this is, you'll see this one when you do programming later. But I will not use, I will not go deep into this one. Okay. This one, so this one is when you see textbook or you see any library books, when it comes to principle of informed momentum, sometimes they give you this presentation. Okay, so basically it's the one that in yellow color and the white color formula on the screen here. Okay. Okay. Maybe we have a short break. Okay, we continue 12:15. 12:15. 12:15.